Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 2 course. Today we are going over Section 2.8, Solving Absolute Value Equations and Inequalities. Now, in the previous lessons, we have learned about inequalities and how they operate, how greater than or equal to operates, and also how the beautiful thing of absolute values works, where you have to have two answers for every absolute value. So let's go ahead and jump into these. These come in two formats. They come in the OR format and the AND format. So with and OR, you have two very key words. Yes, and OR. And what they tell you is one of two things will happen. Either your graph will go in two directions and we'll have two rays, or your graph will be stuck between one number and another. So an example of an OR would be if x is less than or equal to -3, or x is greater than 2. Looking at that, I would put this on my graph. I need a -3, so I'm going to have to go with a 0 here. And then I'm going to have -1, -2, -3, and then a +1 and a +2. At x equals 2, I'm going to have an open circle. At x is equal to -3, I'm going to have a closed dot. And then I have to decide which way does it go. Well, x has to be greater than 2, so 3 is greater than 2, so if true, go through. On the other side, if x is less than -3, then -4 is less than -3, which means that I'm going to be going in the other direction. Notice that there is a gap in my number line that tells me where my x cannot be. If I'm looking at OR, there will almost always be a gap where you do not have any values that work. On the other hand, if you have an AND going on, then you would have something a little bit different. You would have to have x is greater than or equal to -3 and x is less than 2. Well, doing the same thing, right? We have a 0 in the middle, and let's go with pink this time. If we go to the right 2, we'll have an open circle. If we go to the left 3, we'll have a closed dot because of the bar on the -3. And then it would be between them, right? It has to make sure that both statements are true at the same time. So if I go in this direction, then if I'm looking at that one, they don't overlap at all. There are no places where they both overlap, so there would be no solution. But in this case, I know that I have to be greater than -3, which is in that direction. But I also have to be less than 2, which is in that direction. So the only place where these two overlap is between our 2 points. So the way we would draw this one, instead of having two rays going in different directions, is we would have a line segment connecting the two. So for AND, they must overlap. And for OR, they may overlap, but they don't have to. For AND, if they do not overlap, they don't exist. For OR, if they do overlap, oh well, no big deal. Okay? All right, let's go ahead and look at some more examples. These are just going to get really confusing really fast. So let's go over one that is not so difficult to work with. Let's go with an OR example, an AND example, and then look at some absolute values. So the first one is going to be our OR example. And in our OR example, we are going to be given that x plus 3 is less than or equal to 2, or that 3x is greater than 9. To solve an OR means that you have to do both of them. So I'm going to start by solving this equation. The x plus 3 is less than or equal to 2. To do that, I would subtract 3 from both sides, and I would have x is less than or equal to -1. And then for the other one, I see that I have a 3x hanging out, so I'm going to divide both sides by 3 or multiply both sides by 1/3, whichever you prefer. And I end up with x is greater than 3. So I have a case where x is greater than 3 or x is less than or equal to -1. Now I gotta graph it. So I put my number line down, and I have to get a -1 and a +3 in there. So I'm going to put a 0 right here. And that gives me my reference for where -1 is. Since -1 has a solid bar underneath, it gets a dot. And then there's one for +3, which gets a circle because it's not a bar. And then I look at the blue one, right? X has to be greater than 3. So that tells me that I can't go to 0 because 0 isn't bigger than 3. So I go away from 0. And I do the same thing for the green one. X has to be less than or equal to -1. Well, 0 is bigger than -1, so I have to go away from it. And this would give me my OR graph. Now let's do an AND graph. Let's say that we are given the equations -2x is less than 8 and x minus 3 is less than or equal to 2. Now this is an AND one, meaning that wherever they overlap is my solution region. If they do not overlap, then that is not part of my solution region. So let's go ahead and go over these really fast. To do this, we're going to have to solve for the red side and for the blue side. And for the red side, I have -2x is less than 8. To solve for x, I would have to multiply both sides by -1/2. Which means that I would have x and then 4. But when you multiply or divide by a negative number, the sign has to flip. So instead of it going towards the right, it now goes towards the left. So x must be greater than 4. On the other hand, we have x minus 3 is less than or equal to 2. To solve this one, I would add 3 to both sides, and I would have x is less than or equal to 5. So from the looks of it, I think we're going to be trapped between 4 and 5. So I'm going to put a little dot in the middle. I'm going to call that 0. And then I'm going to come over here. Actually, I'm going to call this 4. And I'm going to call this one over here 5. And the middle one will be like 4.5. So for the red one says x has to be greater than 4. Since it's not a solid line underneath, in other words, we don't have a bar, we're going to have an open circle. And then it says x has to be bigger than that, so I know that I'm going towards the right with my purple. Now with my blue, I'm at 5, and because I have a bar, I have a solid dot. Now it says x has to be less than 5. Well, 4 is less than 5, so I know I'm going to be going in that direction. Do we see any overlap? Indeed we do. We see the overlap between 4 and 5, so we would write our graph as a line segment between 4 and 5, where 5 has a solid dot and 4 has a circle. Hopefully everybody's seeing it by now, because that's all the ors and ands that we have time for. We are going to move on to something called absolute values. And with absolute values, you get the same kind of activity going. And this is also why I do the method that I do, where I take the things that are in the inside of the absolute values and I stick a negative on them. Because when it comes to inequalities, that prevents you from getting confused. Because they get confusing really, really, really fast. So let's look at our first example. Let's say that we have the absolute value of x has to be less than or equal to 3. So what this does when we have an absolute value like this is it breaks it into two equations. we have a case where the absolute value of x has a positive version and the absolute value of x has a negative version. In the positive, you just rewrite it. X is less than or equal to 3. In the negative version, you take everything that was inside of our grouping symbol, our absolute value symbols, and you negate them. So we have a negative x is less than or equal to 3. Now, doing some fancy algebra, we end up with x is greater than or equal to negative 3 because I multiplied both sides by negative 1. And then we would draw a graph. Our graph is the same as before. It's a number line. I think we're going to have 0 in the middle, and we're going to go to negative 1, negative 2, negative 3, and we're going to go to 1 to positive 3. And now we have to graph it. So on this part, when it says the positive 3, it says that x has to be less than or equal to it. So I have a solid dot, and I'm going to the left. So all the numbers, to the left of this solid dot are included. And then on the other portion, I have x has to be greater than or equal to negative 3. So at negative 3, I make a solid dot, and everything greater than that has to be included. So what I end up with is a region of overlap right in the middle that says that they have to be between these 2 points. No other numbers work. No other numbers work. Now, what happens when I have an absolute value and the sign is flipped? So let's look at the absolute value of x minus 2 has to be, let's see, the first one was less than or equal to, if I remember correctly. Yeah. And let's say this has to be greater than or equal to 5. All right, doing some fancy arithmetic, we would, of course, change this into 2 equations. The first one would be x minus 2 has to be greater than or equal to 5. But the other one is the negative version. So I would have negative x minus 2 is greater than or equal to 5. And when I do these beautiful little things, I add 2 to both sides over here, so I have x is greater than or equal to 7. And on the negative one, I have negative x plus 2 is greater than or equal to 5, which turns into negative x is greater than or equal to 3, which gives me x is greater than or equal to negative 3. Now I get to redo my nice little inequality. So for this one, it looks like we're going to be going from 0 to 10-ish. So I'm going to put a 0 right here, and I'm going to get a negative 1, negative 2, negative 3 over here, and then a positive 7 to the right. 1, 2, 3, 4, 5, 6, 7. And looking at both of them, I'm going to use pink for both. X has to be greater than or equal to 7. So here's my 7, here's my dot. Is 0 greater than or equal to 7? Well, no. So if false, flee. We have to flee from the 0. And then at the negative 3, we have x is greater than or equal to negative 3. So here's my negative 3. And I messed up. Ooh, uh-oh, bad, Mr. O'Neill. From this line to this line, I didn't flip my sign when I divided by a negative x, did I? Uh-oh. All right. There we go. Yay, we fixed it. All right. See, even mathematicians can make mistakes. So x has to be less than or equal to negative 3, which means that 0 is bigger than that. So if false, flee. And we end up pointing in the other direction. So what does this one look like to you guys? This one looks like an OR equation, right? What did the previous one look like? It looked like an AND equation. So absolute values have both ANDs and ORs in them. We just have to figure them out. If they overlap, it only works in the overlap. And if they don't overlap, well, it's an OR equation. Either one should work. Okay. Hopefully you guys will have a million questions for me. But in the meantime, I think that we are probably just going to move on to our homework assignment. So our homework assignment is going to be on page whatever it is. This is going to be section 2.8. And we're going to do hashtags. Oh, no, this is homework. We're going to be looking at hashtags 1 through 13 odd. 17, 19, 21, 27, 29, 31, and then 33, 43, 47, and 52. I know, there's an even. Oh my goodness. Yes, there's an even. But it's all about good stuff. It's all about absolute values. All right. Well, that is all. Make sure to turn in your homework on time. Make sure to get your homework done. If you have questions, raise your hand. I will be around to you as soon as I possibly can. Good luck and have fun.